Hello and welcome to the Unit 5 Section 2 video on proofs of similar triangles. So just like we had in congruency, we had different ways that we could show that two triangles were congruent. We could do the same for showing that two triangles are similar. So you're going to see a lot of similarity here between what we did with congruency and what we do here with similarity. So let's start off with the first one, angle-angle similarity. So this is used to show that two triangles are similar. Remember, we can't show that two triangles are congruent by angles because they could be different sizes. Well, here we can do it using similarity. Now, if two angles of one triangle are congruent and two angles of another triangle, then the triangles are similar. Now, your question may be, why is it not angle, angle, angle similarity? Well, because we only need two angles, because if two sets of angles are congruent, then we know that the third set of angles are congruent by default. So here we can say that triangle ABC is similar to DEF by angle-angle similarity. So in example 1 here, we're going to explain why the triangles are similar, and we're going to write a similarity statement. So since we know that we have vertical angles here at Q, we know that these angles are going to be congruent. So that's our first set. Now we need a second set. Well, we're told that SR and PT are parallel. If I were to extend these lines and then extend this line here, we would have a transversal where this angle and this angle would be the same because they are alternate interior angles. So extend these lines out for yourself and extend TS out. Extend PT, extend SR, and extend TS, and you'll see that for yourself. This goes back to a Unit 3 concept. Remember, what you have previously learned is on the table as we continue to move forward here. So, since we know those things, then we can say that triangle PQT, so we're looking at no marking, one marking, two marking, is similar to triangle RQS, no marking, one marking, two markings. Okay, remember you have to line up the vertices so that they're in the same order when you do these statements. And we say this is by angle-angle similarity. You need to put the word similarity behind these at this point, and you're going to see why in the next part. Because our next type of similarity is side, 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 which is something that we have for congruency. So this is why you need to specify if you're talking about side, side, side congruency or side, side, side similarity, because they both have the same name. Now, we previously learned that you can check for congruence using side, side, side. However, if the sides are not congruent, we can still check the sides to determine if the triangles are similar. So if the measures of the corresponding sides of two triangles are proportional, then the triangles are similar. So here in this example, ABC is similar to DEF by side, side, side similarity. So we're going to show an example of this one. We're going to verify that PQR and PRS are similar. So we are going to compare our sides. So you've got PQ over PR. So we are basically comparing our shortest side to our shortest side here, okay? Which is going to be 4 to 6, which is 2/3. QR to RS is going to be the same thing. That side comparison is also 4 to 6, which is 2/3. So those are good. Now let's try PR to PS, which is our longest side comparison. That's 6 to 9, and that does reduce to 2/3. So therefore, we can say that triangle PQR is similar to triangle PRS by side-side-side similarity. Our next one is side angle side similarity. So we have previously learned that you can check for congruence using the SAS congruence postulate, the side angle side congruence. However, if two sides are not congruent, we can still check for similarity if the included angles are congruent. Okay, so if the measures of two sides of a triangle are proportional to the measure of the two corresponding sides of another triangle and the included angles are congruent, then the triangles are similar. So here, triangle ABC is similar to DEF because you have sides that are similar and the angle in between is congruent. So let's do an example for this one. We are going to verify that triangle JKL and triangle JMN are similar. Well, here we have a triangle within a triangle, okay? So we know that angle J in both triangles is going to be the same because that's a shared angle. So angle J is congruent to angle J, and this is by the reflexive property. Okay, so that takes care of our angle. Now let's check the sides on either side of the angle. So we're going to compare JK to JM. That gives us 2 over 6, which reduces to 1/3. And then we're going to check JL over JN. So that gives us 3 over 9, which also reduces to 1/3. So the sides are proportional, so therefore we can say that JKL is similar to JMN by side angle side similarity. All right, now let's do example 4. We're going to explain why ABC is similar to DBE, and then we're going to find the length of BE. So first we're just showing why these are similar. So let's see what we have. We have vertical angles. That's always an easy one to spot. Vertical angles are congruent. And if you notice, this looks like the example we did earlier. If we extend AC and we extend ED and we extend CE, you're going to have a transversal going through parallel lines. So you have alternate interior angles here and here. Okay? So we have an angle and we have another angle, an angle and another angle. So they are similar by the angle-angle similarity. So we can say angle-angle similarity is the reason why we are similar. So since they are similar, then we know that the sides can be set up as ratios. So let's do that. We're going to compare AB to DB. Okay, so AB is here, DB is here. It is the side between no marking and one marking, no marking and one marking, so we can make that comparison. We're trying to find BE. Okay, so BE goes with our side DB. So BE is going to go here. So we need to find what side we're comparing with that. Well, BE is between 1 and 2, so we got to compare that to BC, which is also between 1 and 2. So from here, we just plug in our values. AB is 36, DB is 54, BC is 54, and BE is what we're looking for. So cross multiply, you get 36 times BE is equal to 54 squared, which is 2916. And we divide each side by 36, and you get that BE is 81. Okay. One last thing I want to cover briefly here before we end this section is the properties of similarity. The reflexive, symmetric, and transitive properties of equality have corresponding properties of congruence. These properties also hold true for similarity. So we've already covered the congruence in the last unit with these properties, but you can also use it for similarity. And the reflexive property of similarity, triangle ABC is similar to itself, because if two triangles are congruent, then by default they're also similar. Okay, so all congruent triangles are similar, but not all similar triangles are congruent. The symmetric property of similarity states that if triangle ABC is similar to DEF, then triangle DEF is similar to ABC. You can go both ways with it. The only thing that changes, and we've seen this already in this unit, is that the similarity ratio will flip. You'll get the inverse depending on which way you're going. And then the transitive property of similarity, if ABC is similar to DEF and DEF is similar to XYZ, then therefore ABC and XYZ must be similar. So that's just a brief thing to kind of cap off this section of notes. Coming up in the next section, we are going to talk about triangle proportionality.